that how to convert any sum of product into standard or canonical form of SOP. So, standard or canonical form is which form in which each product term has all available input variables. So, we have done this example in the last class, and now we are going uh, to discuss how to represent the sum of product in the binary form. So, the topic is binary representation of a standard product term, that is SOP. So, in this regard, a standard product term is equal to 1 for only one combination of variable value. So every time the product SOP is represented by 1. Now take an example that if we have a product term A, B bar, C, D bar is equals to 1 if and only if A is 1, B is 0, C is 1 and D is 0. So we can say where there is a complement value that will be represented by 0, and where there is a true value the value will be represented by 1. So here we can see that A and C both are in true value. That's why the value of A and C is 1. And on the other hand, B and D are in the complemented form. That is, we have B bar and D bar. That's why the value of B and D is equals to 0. And this product term is denoted by a 1. The value of the product term, that is SOP, will be 1. Now in this regard, so the value of A, B bar, C, D bar is 1 and 0 bar, because B is 0, and 1, C is 1, and as D is 0, D bar. So the value is A 1 and 1 and 1 and 1, that is equals to 1. So in this manner we can find out the binary value of the SOPs. And this term is 0 for all other combination of the values for the variables. Now only for the combination when A is 0, B is A is 1, B is 0, C is 1 and D is 0, the value will be 1. And for the rest of, because there are 4 input variables, that means total 16 combinations are there. Now for the rest 15 combinations, the value of this product term will be 0. Now come to, as we have discussed the sum of product, now we are going to discuss about the product of sum. So SOP and POS in generalized form. The product of sum, as it is clear from the name, product of sum, that means the terms are in the form of OR and we have to product them. So that is POS. When two or more sum terms are multiplied, the result expression is a product of sum. That is the definition. And for an example, suppose we have A bar plus B and A plus B bar plus C. So we can see there are two terms. First term is A bar or C, that is a sum term. Then other term is A or B bar or C. So these both terms are multiplied. So when the expression is in such a way, then it is called POS. We can look into the next example, that suppose A bar or B bar or C bar. This is again a sum term. Then C bar, C plus D bar plus E, again a sum term. Then B bar plus C plus D, again a sum term. All three sum terms are just multiplied, and which results in product of sum. Also it can be like this: A bar and B, A bar plus B bar plus C, and B plus C plus D bar. So it may be possible, if in a general form, that a sum term may be a single, or it may have all input variables. Now in a POS form, a single overbar cannot be extended over more than one variables. However, more than one variable in a term can have an overbar. That is that we have also discussed in SOP, that never it should be when the terms it should never be a complete bar, but the case is all terms can have like an example, that we have A bar or B bar or C bar, it's okay, but we cannot write like A plus B plus C whole bar, because when we expand it with the help of De Morgan's theorem, it will be A bar and B bar and C bar. So that will be a SOP, sum of product. Now implementation of product of sum. Suppose we have an example like X is A.
Oppan Gangnam Style. Gangnam Style. Op, 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 op.